the network for the AV industry.
What are you listening to?
This
is AV.
This
is AVNation.
This is AVNation.
It's Tim Albright with AVNation with an AVNation special, taking a look at RF and wireless. And with us to talk about that very thing, Andrew Kornstein, Manager of Business Development for Sennheiser. Welcome, sir.
Yeah, thanks for having me, Tim.
Absolutely. And Joe Ciaudelli. Joe is the Director of Spectrum and Innovation. Welcome, sir.
Well, thank you. Thanks again.
Absolutely. So RF is one of those areas, I have had a dear friend refer to it as the black magic of AV. Right. It's something that we all use, but very few of us know about it, at least in detail. Joe, as the Director of Spectrum, I'm going to start with you on this. Government, obviously, especially here in the States, but also other governments outside the U.S., cell carriers, they've been kind of moving in and encroaching on RF for, quite frankly, decades. So what is kind of the current state of wireless for installed and also live events RF?
Yes, thank you, Tim. There certainly has been a lot of changes over the past decade. And traditionally, professional wireless microphones operate in vacant, unused UHF TV channels. And however, the traditional UHF TV frequency band has been consolidated, and basically the upper part of it has been repurposed to the mobile broadband cell phone service providers. So this has meant less vacant UHF TV channels for operation of wireless mics. Now, however, the industry was successful at working with the Federal Communications Commission, the FCC, on several fronts to at least partially compensate for the loss of some of the TV channels that wireless mics traditionally operated in. Wireless microphones can still operate in unused TV channels from 470 to 608 megahertz. And, most areas of the country have like 2, 3, 4, or even 4 vacant channels within this range. So you can still very reliably operate wireless mics within locally vacant white space channels. And but also it's important to note that the FCC did in one of their recent rulings, they made a clear distinction between unlicensed mic operators and licensed mic operators. And kind of an important thing to think about is if you are eligible to be a licensed mic operator, you should certainly consider it because it gives you rights and privileges that will give you even greater protection for when you're operating in a professional environment.
Andrew, Joe mentioned there's quite a shrinking of the spectrum here. How does the EWDX line and the equidistant grid work to solve some of those problems with RF?
Right. So we've obviously had to come up with some new innovations in order to combat this shrinking usable spectrum that we have. And the equidistant grid is what we've been able to do with the EWDX. So let's talk about some of the traditional wireless systems. We were always dealing with intermodulation. And what intermodulation basically is it's additional frequencies or RF energy at certain frequencies that are created as a result of 2 or more transmitters. So for example, let's just say I was operating one microphone at 500 megahertz, another one at 501 megahertz. With intermodulation, I would actually get some RF energy at 502 megahertz and 499 megahertz, so below it and above it. What that caused us to do was to have to navigate around those intermodulation products. And what that does, once you start getting into more than 2 microphones, 3 microphones, 10 microphones, 20 microphones in one venue perhaps, it really takes a lot of spectrum real estate by having to navigate around these. With the equidistant grid and the EWDX, we've actually been able to get rid of intermodulation in general. So we're actually able to evenly space our frequencies in about 300 to 400 kilohertz steps in our link density mode. What that can do is give us hundreds of channels potentially to be able to use inside of the small UHF spectrum, because we don't have to navigate around this intermodulation like we used to with some other traditional wireless systems.
So Joe, how exactly, and I'm not asking you to give me, the patent data, but how exactly does this work, when we're on site or when we're setting up?
Well, it certainly makes setup a lot easier because you don't have to calculate all the potential intermodulation products. As Andrew stated, it really provides for excellent spectral efficiency and the ability to pack many mics within a small slice of spectrum. And the way it works is by using highly linear electronic designs. You can think of it this way. Intermodulation is harmonic distortion. And just like how you listen to loud music and you get a ringing in your ear, yep, that's actually a type of intermodulation. It's 2 or more frequencies, in this case audio frequencies, that are exposed to your ear, and if they exceed a certain volume, that's when harmonic distortion happens within your ear. Now imagine if you had an ear that no matter how high you turn up the volume, you don't get that ringing. I think the teenager next door thinks he has that. But basically that's what we do is we create designs that, even though potential RF signals are very high, it never pushes the transmitters and receivers into a nonlinear mode, so that they can just they basically avoid creating intermodulation products.
So for those of you who are wondering, Joe just made a frequency joke because younger people can hear typically higher frequencies. As we all get older, we lose that 20,000 hertz spectrum. So at least this part of we did. I don't know if you guys can still hear the 20,000. As a former tech manager and event tech, one of the most common issues with events or microphones in general really is when you have 2 different speakers or what they call the mic handoff. You've got a very loud talker and then a very quiet talker. Andrew, how does the EWDX solve this issue?
You had mentioned events. It's not even just events. We see this in education, higher education scenarios, convention centers, corporate scenarios as well. The EWDX, and I'll let Joe explain some of the technicals behind it, but we're actually, the specifications say that the RF transmission boasts 134 dB of dynamic range on the RF transmission side. Now, just for reference, 134 dB of dynamic range is about I was looking this up earlier, it's similar to a jet engine about 200 feet away. So if you're seeing a jet engine take off on the runway and you're right there on the tarmac with it, that's going to be about 134 dB. Any other wireless the RF transmission would distort at that sort of loudness, and the EWDX doesn't. So what does this mean in a day-to-day situation? I can take a microphone, I can scream into it, and the RF transmission is going to handle it just as fine as if I'm whispering into it. This is actually another real-world scenario would be switching capsules out. So if you put a dynamic capsule on a handheld versus a Neumann condenser capsule on a handheld, those are both going to have different sensitivities. And what that means in an event scenario or perhaps a classroom scenario, somebody has got to get to that microphone and make an adjustment at the microphone side to the optimal sensitivity level. Well, we've eliminated that variable altogether. So it just means that the technicians or the support team does not have to touch the microphone in that sort of a scenario. So really allows for a lot more stable and hassle-free operation.
All right, Joe. Andrew said you'd explain how it works. So how does this work?
Yeah, I'll let Joe get into that part.
Well, certainly we have to give kudos to our development engineers who spent a lot of time with the battery and current management within the electronic circuit. Okay. And basically, it's when there is a very loud talk, you want that high headroom, and you get that from basically drawing more current, and but you want to do it without, fast draining your battery. So basically, they spent a lot of time in the current design of every stage of the transmitter, so that when the audio portion of the transmitter needs that current, it has it. So I really have to give them a lot of credit for their management and low current design. Also, it's noted that another trick that is done is basically by putting a transistor in a negative feedback loop with the capsule, so that if you have someone who really belts out, it basically prevents distortion right at the microphone level. Oh, wow. Even before it gets into the audio stage and then the RF stage within the transmitter.
One of the aspects of the EWDX line is being able to connect to it remotely and adjust and monitor. Andrew, what are some of the benefits of remote management?
Yeah, so remote management is a big topic when we start talking to our corporate customers and our higher education customers, as well as on the event side. But the EWDX is fully compatible with our control cockpit platform, as well as the wireless systems manager platform. And we have open APIs to be able to use this with any other third-party control system. So if, for example, if you did want to put the battery status readout on a touch panel at a lectern, perhaps, we would be able to do that, or mute status, perhaps. We could do that. With the control cockpit software, this is really designed for a support team or a help desk at a university or a large corporation to be able to troubleshoot issues or anticipate issues before they become major issues. So for example, you could get an alert that says, hey, the microphone in room number 105 has less than 2 hours of battery life. You should go change it. Yeah. So we're able to do that with the control, with the controllability that we have with EWDX. This is the same APIs and the same controllability that we have on our very popular speech line digital wireless, our Team Connect Ceiling 2, and some of our other systems as well. These have been very popular in the past few years.
So with that API, then you can really tie that into any sort of, obviously your guys' dashboard, but also any other management software that, like, let's say an IT department would have.
Yeah, absolutely.
Gentlemen, as we wrap up here, Joe, we'll start on with you. Look ahead and tell me what you see coming down the pipeline for the EWDX line.
Yeah, thank you, Tim. The EWDX is available in the traditional UHF TV band from 470 to 608 megahertz. That is going to serve the vast majority of users and applications. But if you're running a very large configuration in your theater or your campus or your stadium, the EWDX will be offered in alternative bands that we were successful at having the FCC open for licensed wireless microphone operators. And that's an important distinction. You have to be licensed to use these alternate bands. One of the bands is 941.5 to 960 megahertz. And this is a very good band and very clean spectrum. And you do need to do some coordination with the other services within the band, which are mainly studio transmission links used by broadcasters. But you can do that through by studying the FCC database or contacting the Society of Broadcast Engineers. And then if you're doing very big configurations for, a mega event, you can also operate in the 1435 to 1525 megahertz band. And you do have to do some coordination with a agency called AVTRAC, because that band is also used for flight testing. But you would do your coordination with AVTRAC, and that is exceptionally clean spectrum. And so this is very useful for the wireless microphone power users. So we'll be offering the EWDX in these two alternative frequency bands in the future. Thank you.
Joe, you mentioned special licensing, so give people kind of a quick cursor on what are the criteria and how they get some of those licenses.
Sure. So the FCC basically segments wireless micro operation into two categories, licensed and unlicensed. Most operators are operating in an unlicensed fashion. But if you are eligible for a license, you should take advantage of that. And to be eligible for a license, you either need to be a broadcaster or a motion picture operator or someone who makes content for broadcast. Or if you're a theater or a sound company that routinely uses 50 wireless mics or more, then you're also eligible to be a licensed mic operator. And it's noteworthy that actually we've been working with the commission to actually expand license eligibility even more, so that bona fide professional theaters that aren't using 50 wireless microphones can still have the protections and the privileges of a licensed operator. So licensed operation gives you several advantages. First, you have access to additional frequency bands outside the traditional TV band spectrum. You also have priority over any unlicensed user or device, whether it's a wireless microphone or some of these new white space devices that are starting to enter the market. And you can actually reserve TV channels for your production that will block out white space devices from operating in those channels during your event. So it's a big advantage. So if you are eligible for a license, it's highly recommended to apply for it. And it's It's not the easiest process. It's kind of like a tax return to do, but actually your license is good for 10 years and it costs a couple $100, so it's worth it.
Now, Joe, I am curious for myself, does this apply to higher ed campuses or corporate campuses where they may not have 50 in one room, but two in each room times 200? Basically,
within your facility, if in total you're using 50 or more mics, you have reached that threshold. And remember, like ear monitor systems, that counts as a mic. Intercom channels counts as a mic. So, that 50 threshold is if you're in a like, let's say a college campus, you can quickly exceed that. But also, if your campus is doing any broadcasting whatsoever, you're eligible just for being a broadcaster.
Oh yeah, I work with college campuses that have 200, 300, 400 channels of wireless. That adds up very quick.
Very cool. Andrew, same kind of question. What do you see coming down for EWDX?
Yeah, so the current release right now is the 2.5-channel rack variant. Though it is digital transmission, the output on this one is analog. However, very soon we'll have a Dante variant as well. So this will be analog plus Dante. Also, we will be coming out very soon with a networkable charger. I was talking about the controllability of it. Well, you would actually be able to check the battery status, whether or not systems are docked at the end of the night, perhaps. Wow. So that's coming very soon. Power over PoE, which I'm very excited about with the charger. So that's just one plug that charges your battery. So fantastic for the corporate and the higher ed installations. Also, later on in 2023, we'll have a quad receiver. So that'll be 4 receivers in one RU, and that'll have cascadable antennas. So you'll be able to actually have quite a few channels without having any type of antenna distribution with that. So that's coming, as well as, I'm also very excited about this, a gooseneck transmitter. So that's coming in 2023 as well. All of these are updated on our website. If you go to Sennheiser.com/EWDX, it's actually EW-DX, then you'll be able to see the updates on when things are going to start shipping, as well as a lot of the detailed tech specs with this system.
Very cool. And we'll put a link to that on this episode's page as well. Gentlemen, thank you so much. Andrew Kornstein, Manager of Business Development for Sennheiser, and Joe Ciaudelli, Director of Spectrum and Innovation. Thank you both so much.
Thanks, Tim.
Thank you, Tim.
All right. For us, for AVNation, go by our website, avnation.tv. That's avnation.tv. Find more specials like this on there and more. All that and more at AVNation.